So if you choose digits in this range, you're actually choosing from 90,000 digits. But of course, you don't actually have all those choices. So your choice doesn't contain 0, 6, 7, 8, or 9. So actually, you have 5 different choices for each digit. So that gives you a total number of choices of 5 to the 5, which is 3125. Good number to know. So that's how many digits there is in your choice, in your random choice. What we're going to calculate is just an expected value. So the expected number of different digits, this is a bit confusing really, it means distinct digits. Okay, so the number of numbers with one distinct digit, given that they can only contain a 1, 2, 3, 4, or a 5, the number of numbers with one distinct digit, there's 5 of them, we can count them, right? And so on. You get 5, 5, 5, 5, 5, right? So there's 5. So let's get a wee table here. Right. So distinct digits, number of distinct digits. Right. So 1, 2, 3, 4, and 5. So the number of digits in your sample with one distinct digit is 5. With 5 different digits, it's just a number of ways to arrange these 5 numbers. That's just 5 factorial, or 120. Let's count the ones with 2 different digits. So it's not too bad. How do we count the ones with 2 different digits? Well, we just want to think about choosing 2 from 5, right? So how many different ways can you choose 2 from 5? Well, it's just 5, choose 2, which is 10. Right? So there's 10 different ways to choose your digits. Then you're actually counting the number of ways you can form a number with those 2 different digits. And for each, space in your number, you have 2 choices to make with those 2 digits. So suppose I pick, 1 and 3, for example. I can just fill in these with a 1 or a 3, so I have 2 choices for each, giving me 2 to the 5. But of course, I need to take away the 2 that I already counted. Like if I pick 1 for all of them or 3 for all of them, that's just 1 digit. So that's covered in the first case. So that's 10 times 32 minus 2. So this gives us 300 for this case. Okay, the 3 is a bit tricky to work out, so we'll work it out last. We can just work out the 4 for now. So the number of ways to count the numbers with 4 different digits. So in order to do that, you need to choose a digit you're going to leave out. It gives you 5 choices. Then you need to choose a digit that you're going to repeat. It gives you 4 choices. Okay. For example, if we have 1, 2, 3, 3, 5. There I've left out a 4. I could have done that in 5 ways, but I choose left out the 4, and the 1 digit out of the 1, 2, 3, and 5 I've chosen to repeat is the 3. So there's where those choices come from. And then it's just the number of arrangements of this number. And that's just going to be 5 factorial over 2. Okay, so 5 factorial ways, but I'm going to end up double counting because there's 2 3's here. So just divide by 2. Okay. This gives us 20 divided by 2 is 10. So actually 1200. Okay, so you'd expect it to be quite big. You work out the number with 3 distinct digits or 3 different digits. You can do this because it's just 3, 1, 2, 5. Sort of subtracts all of these other things. And if we add them all up, we see this must add to 1500. Okay, so you just do an expectation. Let's calculate the expectation. So I'm not going to do that because I can't be bothered. But it's 1 times the probability, 5 over 3, 1, 2, 5. This is a 1 times the probability, right? Then it's 2 times the probability. So it's 300 over 3, 1, 2, 5. Yeah, and so on. You just add them all up. And you should get this number, 3.3616. What an easy question, really. It's quite beautiful, isn't it? Yeah, really nice though, right? Just think about combinatorics in a natural way, and then really this is, you know, you can do this in a few minutes.